Okay, so moving on to Chapter 2, we're going to try to go through a couple of these little sub-questions for question 45. Write a structural formula for each of the following. So let's go ahead and start off with sub-question A, sec-butyl, tert-butyl ether. So the first thing you have to figure out is this whole ether bit. So if you remember from class in your book, we said ethers were compounds that have an oxygen in the middle, and we're going to have two different R groups coming off of this oxygen. So these two R groups can be the same or they could be different. So all we're saying here is with this R prime is that one R group is something, and then this R prime group is something else. That's all that really means. So if we were to draw it like this, where there were two R groups, that would mean that those two R groups would be, the same. They could be propyl, methyl, ethyl, whatever. They're just the same. Okay, so let's go ahead and get rid of these generic R groups and replace them with something more substantial. So we'll put a sec-butyl on one end and we'll put a tert-butyl on the other end. So the first thing you have to remember is how many carbons are in a butyl group. So methyl, ethyl, propyl, butyl, so that's going to be 4. So we're going to have 4 carbons for each of these, but we have to figure out how to configure the butyl. So you could change the orientation of the carbons and where they're attached to, and that's going to give you a totally different molecule. Okay, so let's just go over and review the sec versus tert versus iso. So if you had 4 carbons all in a chain with no branching at all, that's what we would call the N, or normal butyl. So if you take one of the carbons, let's take carbon 4 and move it up onto carbon 2, that's going to give you a tert butyl. So in this configuration, you have just an attachment point on 2 instead of carbon 1, and then we've also pulled off the carbon 4 from carbon 3 and we've put it on carbon 2. Okay, so this guy right here is the T-butyl or tert butyl. This guy right here is doing the exact same thing, except we're keeping carbon 4 exactly where it was for the normal butyl or N-butyl. So all we're really changing between N-butyl and sec-butyl or S-butyl is where the carbon is attached to whatever the squiggly line indicates. It could be wherever on the rest of the molecule. Okay, so this is going to be sec. Okay, and finally we've got isobutyl, or I-butyl, something like this. It might be notated like superscript I and then Bu. Okay, so and all we've done here is we've basically kept isobutyl the same as N-butyl. All we've done is taken carbon 4 and torn it off from carbon 3 and attached it to carbon 2. Okay, so you can see there are 4 different ways to orient this guy, and they each have their their general features. So going back up to here for S-butyl, so we're going to use this sec-butyl, and all we're going to do, we're still going to use all 4 carbons. We're just going to attach carbon 2 to this oxygen. So carbon 2 is going to go here. We're going to go up 1, so that's going to be our carbon 1, and then we're going to go over here for carbon 3, and then we're going to go down for carbon 4. Okay, so that takes care of the sec-butyl. So now we have to add on the tert-butyl. So tert-butyl, the attachment point is going to be here on carbon 2, and carbon 2 is going to have 1, 2, 3 other methyl groups attached. So we're going to have 1 carbon here, so we're just going to have to add 3 different carbons, or 3 different methyl groups. So 1 methyl group here, 1 methyl group here, and 1 methyl group there. So that's the sec-butyl, tert-butyl, ether. So that question is taken care of. Okay, so moving on to question 2, the isoheptyl alcohol. So first things first, we have to remember that we have an alcohol functionality. So this is what the alcohol functionality is going to look like overall. So all we have to do now is adjust this R group to be an isoheptyl group. So you got to remember how many. You have to remember how many carbons are on the heptyl. So methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl. So we're going to have 7. So we're going to have carbon is going to equal 7. So we're going to go ahead and erase this R group and go ahead and tack on 7 carbons. 1, 2, 3, 4, 5, 6, 7. So now we have 7 carbons, but one thing that we have to make sure we address is this iso bit. So this isn't going to be an N-heptyl, or else it would look like this. The isoheptyl indicates that you're going to have this kind of V structure. in your molecule, such as what's shown here. So all we have to do now is to keep it from being in, convert it to iso. We just have to remove one of these carbons from the very, very end. And we're going to keep it heptyl by adding it back. We're just going to move it back one. Okay. So now we still have 1, 2, 3, 4, 5, 6, 7, but now you can see that we have this iso configuration. Okay. So this guy's taken care of, isoheptyl alcohol. Okay. So now, question E, 1,1-dimethyl cyclohexane. So the first thing you should zoom in on is the hexane bit. So if you're going to draw hexane, you would have 1, 2, 3, 4, 5, 6. But one thing we have to take into account is the cyclo. So that means that this carbon right here is attached to this carbon right here. And that's not very pretty, so let's go ahead and erase it. So I'll go ahead and erase this guy. And just draw a 6-membered ring. So we know it needs to be a cyclic structure, so 1, 2, 3, 4, 5, 6, and go ahead and complete the structure. And okay, so now we've taken care of the cyclo, we've taken care of the hexane, and so this 1,1 configuration is saying that you're going to have two different groups. So this 1,1 and the di is slightly redundant, but we could have a 1,2, which would give you a slightly different answer. But anyway, so we're going to put two different methyl groups, so dimethyl, and we're both going to put them on the 1 position. The great thing about this is that there's no other substituent on the carbon, or on the cyclohexane, so basically you can put it wherever you want. I'm just going to put it down here as an arbitrary position, and this is going to automatically become the 1 position. So right here on the 1 position we have two methyl groups, 1,1-dimethyl, one here, and one here. And so you don't have to put in these Me groups, they're kind of implied, but if you want to put them there, it just kind of reinforces the point. Okay, so next up is J, 5,5-dibromo 2-methyl octane. So again, first thing that you have to take care of is the parent. So oct, methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. 1, 2, 3, 4, 5, 6, 7, 8. So we have our oct. And we don't have our cyclo configuration, so now all we have to do is start attaching groups. So we have to attach two different groups. One is the 2-methyl, and the second group is going to be a dibromo group. And again, this is a very convenient situation where we have both of the bromos on a 5 position. So let's just go ahead and start counting. 1, 2, 3, 4, 5, 6, 7, 8. So let's go ahead and put our methyl on the 2 position. So now here's our methyl group on the 2 position. If you want to, you can add an Me just to make sure your point gets home. And if you really want to, again, you don't have to draw any hydrogens. They're always implicit when they're drawn on carbon. So if you left it just like this, I would understand that there's a hydrogen here. Or if you really want to be explicit, if you really want to make your point, you can always draw that hydrogen in, but you don't have to. Okay, and then the next thing, we're just going to put 2 bromo groups on the 5 position, so we already have this guy drawn up. So let's go ahead and get rid of the number just to make it a little bit more convenient. So this is 5, and we're going to put 2 different bromo groups on there, just like this. Okay, so now we have our 5,5-dibromo 2-methyl octane. Okay, all right. So last but not least, 4-1-methyl ethyl nonane. This is probably one of the more complicated ones, but again, the way that we're going to approach this is we're going to figure out, the overall parent chain first, and then we're just going to start tacking stuff on. Okay, so go ahead and draw the parent, which is going to be a nonane, which is 9 carbons in a row. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the next thing is, if you want to go ahead and number them, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's probably always a good idea to go ahead and number your parent. For these are kind of simple, so it's not absolutely necessary, but for later on, doing mechanisms, naming more complicated compounds, it's always good to go ahead and number stuff, just to make sure you haven't left anything out. Okay, so the question is, where are we going to put this 1-methyl ethyl group? And that question is answered with this 4 notation. So we're going to end up putting something on the 4 position, and we're going to end up putting this 1-methyl ethyl group on there. So what this one methyl ethyl group is saying is that there's going to be a methyl group attached to an ethyl group. Okay, so let's go ahead and add the ethyl group on the 4 position. So methyl and ethyl. So methyl ethyl, and we're going to put a 1 methyl on that group. So the way that you would start numbering this is from where that subgroup is attached. So this would be the 1 position, this would be the 2 position. Okay. So then what we're going to do is put that methyl group on the 1 position right here. Okay. So now we've put the 1 methyl ethyl group on the 4 position of the nonane. So that's the way you would work this problem. Okay, and again, there are, I think, 10 more of these to do. Yep, so there are 10 more of these to do. I would really recommend to just do all of them. Some of them might be super simple, but it's always good to get in a lot of volume of really easy stuff just to make sure that you're really comfortable with naming. Okay. Next question.